Did you know you can derive all of these area formulas just by knowing the area formula of a rectangle? Yep, even a circle. Let's see how. So the area formula of a rectangle is base times height. This tells us how many square units fit inside this shape. So let's start with the parallelogram. How can I morph this into a rectangle? Well, if I move this triangle over here, I get a rectangle with base b and height h. So the area formula of a parallelogram is base times height. Now, what about a triangle? How can we relate this to a rectangle? Well, I see that this triangle is half of this rectangle with base b and height h. These two triangles are congruent to each other. These two triangles are congruent to each other, so this triangle is half of this rectangle. So that is why the area formula of a triangle is half base times height. It's half of a rectangle. Now, for the trapezoid's area formula, here's what we're going to do. We're going to copy, rotate 180 degrees, and paste to get a parallelogram. Now, the parallelogram's area formula is base times height. Base is base 1 plus base 2, height is h. But we have to divide by 2, because we have two trapezoids here, we only want the area of one of them. Now, for a kite, I see that it's half of a rectangle, where the base and the height of the rectangle are determined by the kite's diagonals. So let's call this diagonal 1, let's call this diagonal 2. So the area formula of a kite is half diagonal 1 times diagonal 2. Now let's talk about a regular hexagon. Regular means that all the side lengths are the same and all the angles are of the same measure. So for a regular hexagon, we are going to make triangles like this and let them unravel. So we have the perimeter lined up right here. Then we are going to grab half of the triangles and put them upside down like this. So we get a parallelogram. And we know the area formula of a parallelogram. It's base times height. The base is half the perimeter, and the height is what we call the apothem, the height of each of these triangles. So base times height here is half perimeter times the apothem. And by the way, this works for any regular polygon. So the area formula of any regular polygon is half perimeter times apothem. Now, believe it or not, we can use the same logic to derive the area formula of a circle. Now, this doesn't look like a parallelogram yet, but as the number of wedges increase, meaning we're cutting this into more and more slices, this is going to tend to a rectangle, where the base is half the circumference, pi r, and the height is the radius. So pi r times r gives us pi r squared. So there you have it. All of these area formulas relate back to the area formula of a rectangle.